This is Module 2, Lesson 4, Part 1, and we're going to be talking about measures of position. Measures of position are also referred to as measures of location or measures of relative standing. Oftentimes it depends upon the researcher or the textbook author that you're using as to what terminology is used. Measures of position are used to compare data values from different data sets, even if you have different measurement units. For example, if you were looking at the weights of professional athletes, and you had one data set that had the weights in pounds and another data set that had the weights in grams, you could still make comparisons even though you have two different measurement units. Also, measures of position can be used to compare data values within the same data set to see which value is, in a sense, more extreme than another. You can also use measures of position to help determine whether or not there are outliers within a data set. Identifying outliers is important because they can influence or affect your calculations of the mean and the standard deviation and other statistics. We're going to look at two of the more commonly used measures of position. First of all, we're going to take a look at percentiles in this video, part 1, and then in part 2, we're going to take a look at the Z, or the standard scores. So let's focus on percentiles for a minute. Percentiles are a position measure, or a measure of position. You can see it used a lot, especially in education. We talk about whether a student's test scores are within the 75th percentile or the 80th percentile. We also look at that, see that in health-related fields, with especially as it relates to children. They look at whether they're in the 80th percentile for their growth. And things like that. You could also see measures of position used in the criminal justice field as well as psychology. What a percentile does is it takes the data set and divides it into 100 equally sized groups so that each group contains 1% of the data. One of the benefits, again, I've kind of alluded to, we use percentiles to compare how an individual data value compares to what is often referred to as the national norm. For example, if you take the ACT math test and you score 25, when you get your score report back, it may say that your score of 25 on the ACT math test is in the 90th percentile. What they're doing there is they've taken your score and compared it to all the other individuals who took the test, and they're looking at how your score compares, and we'll talk about the interpretation a little bit more in just a minute. We represent percentiles with a capital P. Hopefully that makes sense. Percentile starts with P, so we use a P with a subscript, and the number in the subscript represents which percentile you're looking for. So if you have P with a subscript of 2, you're trying to determine the second percentile. If you have P with a subscript of 75, you're looking for the 75th percentile. The primary thing that you need to understand as it relates to percentiles is how to interpret them. And the interpretation of a percentile, we always talk about the percentage of data that falls below that particular value. The percentage of data values that fall below, that's the key. It's always what percentage falls below that specific rank. One of the challenges we face when we're dealing with percentiles is that there are multiple ways, there are different formulas for calculating a percentile. Sometimes it depends upon the researcher, it could depend upon the textbook author, it could also depend upon whether your data set is symmetric or whether it is skewed. And so we're not going to get caught up in all of those different formulas. We're going to let the calculator or the computer do the work for us. And we're actually going to talk about a very specific type of percentile called a quartile. The primary difference between a quartile and a percentile is that quartiles are the numbers, are the numeric values that separate the data into quarters, where each quarter contains 25% of the data. So let me see if I can maybe sketch you a picture here of what this would look like. Okay, so you would have your number line of your data, you would have to rank them. So you would have it ranked with the minimum up to the maximum. And then you're going to divide it into 4 equal sections so that you would have quartile 1, quartile 2, which also represents the median, and then quartile 3. And then in each group between the minimum and quartile 1, you have 25%. Between quartile 1 and quartile 2, you have an additional 25%. So that actually, if you look at quartile 2, you have a total of 50% below quartile 2, or what we call the median. Between quartile 2 and quartile 3, there's an additional 25%. And then between quartile 3 and the maximum, there is the final 25%. And again, the important thing to remember is you always interpret it as the amount of data that falls below. So if I'm at quartile 1, then that means that there is 25% below that value, while there is 75% above. Okay, so you want to think about and pay attention to the quartiles. Now, another thing to think about here is the first quartile would be the same as percentile 25. The second quartile is the same as percentile 50, and quartile 3 is the same as percentile 75. One of the other numbers or statistics that we look at in relationship to quartiles or percentiles is we look at what's called the interquartile range. The interquartile range represents the spread of the middle 50%, and it's an important value because that helps us to determine whether or not our data set has any outliers. Now, your calculator and the website will calculate this for you, but what they're calculating is to calculate the interquartile range, also shortened to IQR, is you take the third quartile minus the first quartile. So for example, if we go back and look at this picture, our interquartile range again runs from quartile 1 up to quartile 3. So, and again, that represents the middle 50% of the data, and it's called the IQR. And again, we use that value to help us look at whether or not we have outliers. All right, so let's think about outliers for just a minute. An outlier is a data value. It could be 1, it could be 2, it could be 5. It's a data value that is significantly different from all of the others. Maybe you have a really, really low value, or you have a really, really high value, or values that for whatever reason just don't go with the rest of the data set. I always think about almost like a cow standing out in the middle of the field. It's outlying in the field. It's out there all by itself, and there's no other cows or other animals around it. So an outlier is just kind of one of those values that's really out there, if you want to think about it that way. And they can occur within a data set. Sometimes it's possibly related to an error where perhaps maybe you misread the measuring tool, or you used the measuring tool incorrectly, or you just read it wrong. You wrote it down wrong where you can't read your handwriting, or it got mistyped. Maybe you reversed the numbers. So there could be a recording error that causes the outliers. It could be that the response came from someone that really wasn't part of the study. It was from a participant that does not belong to the defined population. For example, if the study has to do with females and you include a male, then the responses from the male very well could be considered or possibly outliers because he wasn't part of a male was not part of the original population. Honestly, an outlier sometimes can be a legitimate response that simply occurred by chance. It's a valid number and we can use it. It's important to recognize or to determine if your data set has outliers because the outliers can influence and affect the calculations of your measures of center and measures of variation, specifically the mean and the standard deviation. An outlier can cause the mean or the standard deviation to be too high or too low, inflated or deflated, depending upon what type of outliers you have in the system. Now, basically, to make the decision whether or not you have any outliers, we use a formula. And here's the guidelines or the formula for making that determination. Any data value that is less than Q1 minus 1.5 times IQR, or any data value that is greater than Q3 plus 1.5 times IQR is considered an outlier for the data set. And let me see if I can kind of show you a picture so you get a sense of what this means. So again, you would have your data set divided up so that you have your minimum, your maximum, and then you have your data set divided into 4 equal parts so that you have quartile 1, the median, and quartile 3. Now, using these formulas, what's going to happen is you're going to calculate from Q1, you're going to do Q1 minus 1.5 times the interquartile range. And that value kind of creates like this fence post or this cutoff value. You also have that same option on the high end. You go Q3 plus 1.5 times the IQR. And again, you have that fence post, if you will, created. And so what this guideline says is that any data value that is basically outside the fence, anything that's out here on these extremes would be considered an outlier. Okay, so any data value less than Q1 minus 1.5 IQR would be an outlier. Any data value more or greater than Q3 plus 1.5 IQR would be considered an outlier. And we'll take a look at how to use this formula a little bit later in another video.